Hello, members of the Hydrogen Water Group on Facebook and anybody else who might be watching this video. My name is Randy Sharp, and over the past few months we've been discussing on a couple of different posts the SMPS power supply and how it relates to water ionizers. There does appear to be some confusion about what an SMPS power supply is and how it actually works. And I thought by building this little demonstrator and hooking an oscilloscope to it, I could give you a visual representation of what's taking place when you select different pHs on the front panel of a water ionizer. First of all, this board is made up of a main transformer. All ionizers have main transformers because you have to convert the 120 volt AC from the wall to a usable DC output. This particular transformer is from an old printer that I had to toss. It produces 12 volts, and I connect that 12 volts to the input to this SMPS power supply that I bought off the internet to control a DC motor in the shop. The way this SMPS power supply is controlled is through this variable resistor that I have hooked up. I've labeled it with some 8.5, 9.0, and 9.5 labels to simulate the push buttons on the front of a water ionizer. I also hooked up this light bulb, which you'll be able to see will change as I change the setting on the SMPS power supply. Now you'll also be able to see the changing waveform on the oscilloscope as I make these changes. I'd like to start by showing you that right now I'm at the what I call the 8.5 setting, and the waveform shows that it spends most of its time in this lower position, or the 0 volts position on the oscilloscope, and very little time in the upper position, or the 12 volt position on the oscilloscope. Now watch what happens as I slowly increase the potentiometer and increase the voltage to the light bulb. You can see it's getting brighter, but look at what happens to the top part of that waveform as I increase this. Notice how wide the pulse width is getting, and now at the maximum position it spends almost all of its time in the on position and just drops down very short period of time on the off position. So we're now delivering maximum amount of current flow to the light bulb, which represents, of course, the current we would be delivering to the electrolysis electrodes inside the chambers. Now I'm going to change that back and forth a few times just so you can see that there's a minimum and there's maximum. Now the actual rate at which this is occurring, the scope is giving me a readout of about 600 hertz, which is about 600 times a second, which in the electronics world is really pretty slow, but in any event, it does take a solid state device called a thyristor or an SCR to actually accomplish that. You can't do that kind of speed with a relay, for example. In any event, I hope that this has shown you how an SMPS works and maybe have taken some of the mystery out of it for you. If you still have questions about it, please feel free to get a hold of me. My name is Randy Sharp. I spend a lot of time on the Hydrogen Water Group on Facebook and be glad to answer any questions for you.